Yeah, welcome back guys to another video. It's your boy Sam. Hope you all are doing great. In this tutorial right here, what we're going to do is we're going to predict the stock price of Tesla using an artificial neural network. And this is going to be done with Python. And artificial neural network is for sure a topic in machine learning. So if you're into machine learning, this will be a nice tutorial to actually get involved and understand some things about machine learning. But before we get started, I want to put a real quick disclaimer here, which is I am in no way giving financial advice in this video. What we're doing right here is we're just looking at the whole concept of using machine learning to predict outcomes from previous outcomes. So that's the whole purpose of this, and that's what this video is about. Now, we'll be using Google's website, which is collab.google.com, because it makes it very easy to start programming in Python, meaning you don't have to install Python into your computer. The program we're about to build uses artificial recurrent neural network called long short-term memory to predict the closing stock price of any corporation. And in this case, we will be using Tesla, and we'll also be using the past 60-day stock prices. Now let's talk more about this LSTM, which is long short-term memory. Long short-term memory is an artificial recurrent neural network architecture used in the field of deep learning. Unlike standard feed-forward neural network, LSTM uses feedback connections. It can not only process single data points, such as images, but also entire sequence of data, such as speech or video. For example, LSTM is applicable for tasks such as unsegmented connection handwriting recognition. LSTM are widely used for sequence prediction problems that have proven to be extremely effective. And the reason they work so well is because LSTM is able to store past information that is important and forget the information that is not important. Now let's get to coding. We have a block already of code. So what we're going to do in this block is let's import. So we're going to we import all the necessary libraries we need. We import math because we'll need math. We'll also import Numpy as NP. After that, we'll import MATPLOTLIB because we're creating a kind of like graph, because that's how you actually read stock prices. .py plot as PLT. We're also going to import Pandas as PD. We'll import Pandas data reader as well. Underscore data reader as web. And we'll also import datetime as DT. After that, we'll say from sklearn dot preprocessing we want to import min max scalar, and also from keras dot models we import sequential, and from keras dot layers we import dense. We also import dropouts and LSTM. Now after that, what we'll do is we'll say plt dot style dot use, and we'll use the 5 538. Now the good thing is this block is we can run it to see if everything is working out well. So this way we're able to run each block to make sure we don't have an error. And we can see here we have an error. It should be matplotlib, you see? So that's why this is nice. We run it again. And we can see that we didn't get any error message, so this part of the code is correct and everything is working out well. Now what we do next is we click on this code to get another code block. What we're going to do next is we're going to get the stock code. And we do that, we write df is equal to web.dataReader. And here I'm going to put CSLA, that's for Tesla. After that we say data source, Yahoo, because we're getting it from Yahoo Finance. Then we tell it where we want to start at. And in this case, we're starting at 2012-01-01. And we end at 2021. End at 2021-05-05. Now, for us to actually see it, we need to show the data. We just do df. I'm going to enlarge this a little bit. Yeah, it's looking quite small. Now we run this. Now you can see we get the whole stock quote from 2012 to 2021. I'm gonna click on code again. What we want to do next is we want to get the number of rows and columns in the data set. So we just say df.shape. If we run this, you can see we get 2,350 and then 6. We know we have columns of 6 here, 1, 2, 3, 4, 5, 6, where it shows high, low, open, close, volume, and edge close. Click on code again. What we want to do next is we want to visualize the closing price history. I would say plt the figure. I would say fig size. So fig size equals to 16.8. Say plt again. Dot title. Close price. Close price history. Another plt. Dot plot. Say df. Close. After that again we say plt.x label, and we also have a y label, and after that we're just going to show it. So we say x label, font size, is equal to 18. PLT, the Y label. What we want on the Y label is we want it to actually say close price in USD. And we also want this, the font size, to be the same, to be equal to 18. Now we just say PLT dot show. Now we're gonna run this. If we have any error, it's gonna show us, but if we don't, you can see that actually Tesla wasn't really that big. It's just now that the prices have gone really high. So it's nice to use Tesla because we can see, I don't even think Tesla was really founded in 2012. So that's why you see it's really low. No, let's check when Tesla was founded or when Tesla went into the stock exchange. Okay, so okay, it was in 2010, but it was really low. Okay, so it went into the stock exchange in the first year in the stock exchange was 2010. But you can see it's very low, and just now in 2020 actually that you can see it really peaked up the closing prices. What we need to do next is we need to create a new data frame with only the close column. And after that, when we create that, we're going to convert that data frame to a NumPy array. When we convert it to a NumPy array, we'll get the number of rows to train the model on. So right here, we'll say data is equal to df, the filter, and put close here. And the way we do that is we'll say data set is equal to data dot values. So we're going to say training underscore data underscore len is equal to math dot seal. And we say the length of data set. I want to train this module on 90% of the data that we have, so that's why I'm going to do dot 9. That's just basically saying 90%. And after this, you just call training data len. So we run this. Now I'm going to create another block. So what we're going to do here is we're going to basically scale the data. So we'll say scalar is equal to min max scalar. And you put feature range. It's going to be 0.1. And then we'll also put scaled. Now we're going to create a variable called scaled underscore data. I'll say scalar dot fit underscore transform. I'll say data set. After that, we just call the variable so we can print it. Run this, and you can see right here we get an array of it. What we're going to do is we're going to create the scaled training data set. So we say we create a variable called I just realized I spelled training wrong. Yeah, just so you know, I spelled training wrong. I can change it, but yeah, it should be in. Just change it. Say train underscore data is equal to scaled underscore data 0 0 colon training data length, and then we put a colon there. After that we say x underscore train is equal to an empty array, y underscore train is equal to an empty array. Now we say for I in range, for I in range 60 len train underscore data x underscore train dot append train underscore data I dash 60 and 0. Now we say y underscore train dot append train underscore data I 0. Now we have a condition after that that says if I is less than or equal to 60, you need to print underscore train x dot underscore train, and this will be y train, and then we just print. Now we run this, and you can see right here we created the module that we're going to use to train the stock. Next thing we do is we're going to convert the x train and the y train. We're going to convert the x train and the y train to a numpy arrays. So we say x underscore train and y underscore train. We set that equal to np dot array x underscore train, and basically the same thing. Just gonna copy it, and this is y. Now we run that, What we do next is we reshape the data. So we say x underscore train is equal to np dot reshape x train dot shape 0 x underscore train dot shape 1 and 1. Now we say x train dot shape. We say x train dot shape. Now what we're going to do next is we're going to build the Lstm module or the Lstm model. And do that, we just say model is equal to sequential with a capital. Now we say model dot add Lstm, we say 50, return sequence is true, input underscore shape is equal to x train dot shape, start at 1 and 1. Now we add model again, dot add Lstm 50, and the return sequence is false. Then model dot add dense 25. Dense, and then it's 1. Now we make sure we don't have an error. Yep, we don't. What we need to do next is we need to compile the model. So we say model dot compile optimizer Adam and loss. What's up with this whole script that I don't need the information. Mean underscore square squared underscore error. Now we run it. It's working well. Now we actually trained the model. So we say model dot fit underscore x underscore train y underscore train batch size 1 and epoch 1. Run it. It's gonna take a little bit longer because we're actually training it, and you can see it right. You can see it down below here. Now we're going to create a testing data set. So we'll say test underscore data is equal to scaled data and we said training data length minus 60 after that we say x underscore test is equal to square brackets y underscore test is equal to dataset dot training length. After that we say for I in range 60 and test underscore data x underscore test dot append test underscore data minus 60 I, yeah, 0. So we have an error here. It's supposed to be for I in. Yeah, so that works perfectly. What we need to do next is we need to convert this data to a numpy. So we say x underscore test is equal to np dot array x underscore test. After that, we'll say x underscore test is equal to np dot reshape at x test dot shape. We start at 0. X underscore test dot shape, and that's 1. Next thing, we need to get the model's prediction price values. Now we'll create a variable called predictions, make that equal to model dot predict x underscore test. Then we'll say predictions is equal to scalar dot inverse transform prediction. What next is that we'll get the root mean squared error. So we'll get the RMSE. So say RMSE is equal to NP dot square root NP dot mean NP dot mean, and then we'll say prediction minus y test star 2. Now we print RMSE. Now we run it and get this right here. Now it's time for us to plot the data and visualize the data. To plot the data, we'll say train is equal to data training data len. We'll say valid is equal to data in square brackets training len. After that, a colon. So say valid predictions is equal to predictions. And after we do that, then we need to visualize the data. So say plt dot figure is equal to fixed size 16:8 plt dot title model and also plt dot x label data font size is equal to 18 plt dot y label close price USD, and then we put the $sign. Font size is equal to 18. And plt dot plot dot plot train, and then we put close plt dot plot valid close prediction plt dot legend train val predictions, then we say log is equal to lower right. plt.show, and hopefully we don't get an error. Run this. And yeah, guys, you can see right here that we have our prediction, which is this color here. And you can see it's very similar, that it goes quite alright. It's not 100% accurate, but with this, you can see the value, which is the red right here. And you can see that the prediction actually is quite similar. Like I said earlier in this video, this is not the only thing you should do when predicting stock prices. You should also do your own research and actually check stock markets and check the websites that actually show changes in the stock exchange market. But this right here did basically what we wanted the program to do. So hopefully you enjoyed it. If you did, please leave a like. I was not able to explain everything step by step because this is really in the domain of machine learning, and for sure, if you guys want, let me know in the comments below. I will create a course that actually explains every step that we made and also the calculations and why we made those calculations and all that so you understand it fully. But yeah, this is just a project and you'll be able to get the source code in the description below. And yeah, guys, please like the vid, subscribe if you're new, and I'll see you all in the next YouTube video.